Okay, I hope you're all doing well. This is lecture 2, supposedly the second day of class, but who's counting? So we're getting back to some of the memory issues, and memory is an absolutely huge topic. We're just kind of scraping the surface of this, and there's just a couple high-level things you need to know, at least take away from the course. The issue is that if you ever have to work with memory, you're going to have to get out the data sheet and spend time staring at it. So we're not really going to go to that level. We're just pretty much speaking in high-level terms here. Okay. So this slide is pretty much a review from what we were talking about before. I made up the terms incidental and structured memory. Typically, small memory such as like a register here and there or a flip-flop, I call that incidental memory. What we're more interested in is structured memory, and that's going to be something big like a RAM or ROM. So the issue here is RAM and ROM. They're both random access. We'll be working with RAMs in this class. The characteristics that you want to take away from these is the fact that RAMs are readable and writable, but they're volatile as well. I mean, you turn the power off, you lose your data. ROMs, typically speaking, are only readable, but you turn the power off, you don't lose the data. So this is a generic piece of memory here. Has 3 types of inputs and outputs, I guess. Data inputs and outputs, address and control. So these memories are analogous to an array in programming language, meaning an array you have to get at the data, you have to give it an index somehow to get that data. But in hardware, what we're going to do is give it an address. So that's analogous to the index in programming. So in this memory here, it has some address lines. There's a given number of address lines. That number of address lines determines how many chunks of data that memory can store. So it's always a function of binary function, an exponential function of 2. So if you have 10 address lines, you have 2 to the 10th possible pieces of data you're going to store. The output, or the data that goes in and out of these, is referred to as words. Words doesn't really have a solid meaning such as byte. Word can be anything. Pretty much when you hear a word, you have to have that person define it, whoever's using that word. So these memories, one of the things we're interested in is the capacity, typically in bits and bytes. So the bit capacity is just the number of storage locations, which is 2 raised to the number of address lines times the number of bits in the word. And we'll say something like, if we want to get a byte, number of the byte capacity, we'll take this term here and divide it by 8. So the 2 operations we're interested in is kind of putting data into that memory and taking it out of memory. So when I put data into memory, it's essentially going to be a write operation. When I take data out of memory, it's going to be a read operation. So unless otherwise stated, when I'm reading data from memory, I'm just copying that data to something external from memory. I'm not changing the data in the memory. When I'm writing data to memory, I am actually going to change data at a given address in memory. And so essentially these high-level how to do a read operation is give it an address. That's the data. It's specifying which piece of data you want to read, and then I'm going to tweak the control lines. So tweak the control lines is just generic term. Every memory is going to have a different way to do it. So when I'm writing stuff, I need to give it data and give it an address and then tweak the control lines. So generally speaking, these are the roughly high level what we need to do to read and write memory. Okay, so this I just threw this together. I made it up. It's not nothing big deal or anything like that. The point, and I made up these control signals also. So CS and OE are control signals. Generally speaking, CS is a chip select, OE is an output enable. That's not a big deal. So essentially, this is a read operation. Essentially, I'm going to throw it an address, throw it some control, and sometime later, I'm going to get the data I want. And so this time between I give it the address and control lines and get the data is referred to as a read access time. So it comes by many names, but the important thing is it's not instantaneous. It takes some time. So similar with a write operation, except for writing I gotta give it some data. So essentially I am going to once again give it an address, maybe give it some data, and tweak the control lines. And so it's going to take time to write this thing into memory. So from the time I give it the address to the time when the data I'm writing to it actually gets written to it is, it's a finite amount of time. And typically I like referring to it as the write cycle time. It comes by different names. Different people call it different things, but the point is it's not instantaneous. So neither a read operation or a write operation is instantaneous. That's what I'm hoping you take away from this. So the memory performance parameters, it's always an issue of how fast I can read and write the thing, and related to that is memory bandwidth. So the read access time and the write cycle time is the amount of time I need to read and write data from this thing. Yeah, whatever. We went over that. But the more important thing, what I want you to take away from this is memory bandwidth. So for any given memory, you could only get so much data into it and out of it over a given time. So this is a rate. So this is amount of data per unit time. It's not like the amount of data or anything like that. The bandwidth is a rate measurement. So this is actually super important. You think, oh, I got a memory, whatever. But the issue is, in a real system, typically you'll have multiple devices that are accessing the memory, and they cannot access the memory at the same time. So you're going to have, bandwidth issues. And so the issue is what I'm afraid of this course and this suddenly online. I'm afraid Cal Poly and the world in general is not really ready to be transferring tons of data all at the same time. So tomorrow or someday at 11:10, it's when classes are in session. We'll see if the memory bandwidth breaks down. And so it's gonna break down if you got delays or it just hangs. So anyway, the way to get around bandwidth issues is to reduce the access time and write cycle time. So just get a faster memory. It's the issue with faster memory. It is more expensive memory. And that's it.